So our next questions are the first principle questions. This will come compulsory for 4 marks. It is a very important question. So the question is, find the derivative of the following functions from the first principle with the respect to x. Okay. So the question is root of x plus 1. So let the function f of x is equals to root of x plus 1. So the function f of x plus h can written as, in place of x in the given function, we should replace it with x plus h. So it will be root of x plus h plus 1. From first principle of derivatives, we can write as f dash of x is equals to limit h x tends to 0 f of x plus h minus f of x by h. This is the formula of first principle. You have to remember this in order to solve this question. So we can write as f dash of x equals to limit h x tends to 0. The value of f of x plus h is this. We'll substitute root of x plus h plus 1 minus f of x is root of x plus 1 by h. Now whenever there is a term in roots, we rationalize the numerator. Okay, so it is f dash of x equals to limit h x tends to 0 root of x plus h plus 1 minus root of x plus 1 by h into, we have to write the opposite sign of this term. So it is root of x plus h plus 1 plus root of x plus 1 by root of x plus h plus 1 plus root of x plus 1. This is in the formula a minus b into a plus b, which is a square minus b square. So it is limit h x tends to 0. A is root of x plus h plus 1 square minus root of x plus 1 square by h into this term root of x plus h plus 1 into plus root of x plus 1. Okay, so the square and root of these two terms gets cancelled, so we are remaining with limit h x tends to 0 x plus h plus 1 minus multiplying inside, so it is minus x plus into minus is minus 1 by h into root of x plus h plus 1 plus root of x plus 1. So here the plus x minus x gets cancelled, plus 1 and minus 1 also gets cancelled. So our equation is f dash of x is equals to limit h x tends to 0. We are remaining with h by h into root of x plus h plus 1 plus root of x plus 1. Here h gets cancelled. Now substitute the value of h to 0 in this equation. So it is f dash of x is equals to 1 by root of x plus h becomes 0 plus 1 into root x plus 1. So here it is x plus 1 root x plus 1 into plus is in the middle plus root x plus 1 is equals to, we can add up both, so it is 2 root x plus 1. Our next question is, the function is sin 2x. Solution, f of x equals to sin 2x. So f of x plus h is equals to sin, in place of x substitute x plus h, so it is 2 into x plus h equals to sin 2 into x 2x plus 2 into h 2h. Okay, now writing the formula of first principle, it is first principle derivative is f dash of x is equals to limit h x tends to 0 f of x plus h minus f of x by h. So we can write f dash of x is equals to limit h x tends to 0 f of x plus h value is sin 2x plus 2h minus f of x is sin 2x by h. Now you should remember the formula of this is in the form sin c minus sin d. Sin c minus sin d is equals to 2 cos c plus d by 2 into sin c minus d by 2. Substituting this here, so it is f dash of x is equals to limit h extends to 0, 2 cos, this is c, this complete is c, and this is d. So it is 2x plus 2h plus 2x by 2 into sin 2x plus 2h minus 2x by 2 whole by h. So here this plus 2x and this minus 2x gets cancelled, and here we need to add the x term. So it is f dash of x equals to limit h extends to 0, 2 cos 2x plus 2x is 4x plus 2h by 2 into sin 2h by 2. Here also this 2 gets cancelled by h. Now taking 2 common in the numerator here in these two terms, so it is f dash of x is equals to limit h extends to 0, 2 cos 2 common, so it is 2x plus h by 2 into sin h by h. Here this 2 and this 2 gets cancelled. Now writing the limits to this both term, here there are two terms, 2 cos is the one term and sin h is the another term. So it is limit h extends to 0, 2 cos 2x plus h into, writing the limit for this term also, limit h extends to 0 sin h by h. This h is for the both, right, because it is in multiplication. So I'm writing this h to with respect to only sign, because there is one formula which is limit theta extends to 0, sin theta by theta is equals to 1. You should remember this formula. So this is in that form only. Here the theta is same, so this can be written as 1. F dash of x is equals to, here substitute 0 in place of h, so it is 2 cos 2x plus 0 into 1, that is equals to 2 cos 2x. Our next function is cos ax. Solution, f of x is equals to cos ax, f dash x plus h is equals to cos a into x plus h. Multiplying a inside, so it is cos ax plus ah. Now writing the first principal formula, principal derivative is f dash of x is equals to f of x plus h minus f of x by h. So limit h extends to 0. Okay, so it is f dash of x is equals to limit h extends to 0, substituting the value of f of x plus h, which is cos ax plus ah minus f of x is cos ax by h. Now we shall write the formula of cos c minus cos d. The formula is minus 2 sin c plus d by 2 into sin c minus d by 2. So this can be written as f of x is equals to, f dash of x is equals to limit h extends to 0, minus 2 sin, this is completely c and this is d, so it is ax plus ax by 2 into sin ax plus minus ax by 2. Here this 2 gets cancelled, whole by h. Now adding the ax terms, so it is f dash of x is equals to limit h extends to 0, minus 2 sin 2ax plus by 2 into sin by 2 whole by h. Now writing this limits to both the terms, so it is f dash of x is equals to limit h extends to 0 minus 2 sine 2ax plus ah by 2 into limit h extends to 0 sine ah by 2 by h. Okay, so here substituting the value of h as 0, f dash of x is equals to minus 2 sine 2ax plus a into 0 by 2. Here it is again the formula limit h extends to 0 sine a theta by theta is equals to a. So here it is sine, this term is completely a theta by theta. Okay, so this is a, so it will be a by 2. Here cancelling this 2 and this 2, so it is f dash of x is equals to minus 2 sine ax into a by 2. So this 2 and this 2 gets cancelled, so it is minus a, here a is left, sine ax. So our next function is tan2x. Solution, the given function f of x is equals to tan2x, f of x plus h is equals to tan 2 into, in the place of x substitute x plus h, so this is equals to multiplying 2 inside, so it is tan 2x plus 2h. Now the formula of first principle is f dash of x is equals to limit h extends to 0 f of x plus h minus f of x by h. Substituting the values, f dash of x is equals to limit h extends to 0, f of x plus h value is tan 2x plus 2h minus tan 2x by h. In order to solve the first principle sum, the given function should be in terms of sine and cos. So we have to convert tan in terms of sine and cos. So we know the formula of tan is sine a by cos a. So we'll write it as f dash of x is equals to limit h extends to 0 sine 2x plus 2h by cos 2x plus 2h minus sine 2x by cos 2x whole by h. Now taking the LCM, so this term goes here and this multiplies to this term. So it is f dash of x is equals to limit h extends to 0 sine 2x plus 2h into cos 2x minus cos 2x plus 2h into sine 2x by h into cos 2x plus 2h into cos 2x. Now here this is the formula of sin A cos B minus cos A sin B. So it is sin A minus B. Limit h extends to 0, it is sin A minus B. A is 2x plus 2h minus B is cos x, 2x, h into cos 2x plus 2h into cos 2x. Here plus 2x and minus 2x gets cancelled. Now we can write the given function f dash of x is equals to limit h extends to 0 sine, we are left with 2h by h into limit h extends to 0 1 by cos 2x plus 2h into cos 2x. Here again it is the formula limit h extends to 0 sine a theta by theta is a. So the value of a here is 2 into substituting h equals to 0 here. So it is cos 2x plus 2 into 0 into cos 2x. So 2 ones are 2 by cos 2x into cos 2x. So it is cos square 2x. And 1 by cos is secant. So we can write it as 2 secant square 2x. So our next function is secant3x. So f of x is equals to secant3x. F of x plus h can be written as, in place of x we'll write x plus h and multiplying 3 inside. So 3 into x is 3x, 3 into h is 3h. Now writing the formula of first principle, f dash of x is equals to limit h extends to 0, f of x plus h minus f of x by h. Substituting the values, so it is limit h extends to 0, secant 3x plus 3h minus secant 3x by h. Now secant is 1 by cos, writing it as 1 by cos function. So it is limit h extends to 0, 1 by cos 3x plus 3h minus 1 by cos 3x whole by h. Taking LCM here, this terms goes there and this comes over here. So it is limit h extends to 0, cos 3x minus cos 3x plus 3h whole by h into cos 3x plus 3h into cos 3x. Okay, now writing the formula of cos c minus cos d, the formula of cos c minus cos d is equals to minus 2 sine c plus d by 2 into sine c minus d by 2. Substituting in the formula, so it is limit h extends to 0, minus 2 sine, this term is c and this term is d. So it is 3x plus 3x plus 3h by 2 into sine 3x minus 3x plus 3h by 2 whole by h into cos 3x plus 3h into cos 3x. Here this negative is inside, so this gets cancelled, and here adding up the x terms, so it is f of x is equals to limit h extends to 0, so this will become minus 2 sine 3x plus 3x is 6x plus 3h by 2 into sine, this minus multiplies inside, so it is minus 3h by 2 whole by h into cos 3x plus 3h into cos 3x. Now writing the limit for the both the terms, so f dash of x is equals to limit h extends to 0, minus 2 sine 6x plus 3h by 2 whole by cos 3x plus 3h into cos 3x into limit h extends to 0, h with the sign. So it is sine minus 3h by 2 by h. Okay. Now substituting the value of h equal to 0 in this term, so we'll get f dash of x is equals to limit, sorry, there's no limit now, substituting the value, so minus 2 sine 6x plus 3 into 0 by 2 whole by cos 3x plus 3 into 0 into cos 3x. And here the formula is sine a theta by theta is equals to a, so it is into 3 by 2. Okay, so here this 2 and this 2 gets cancelled, this minus multiplies with this minus, so minus minus becomes plus, so f dash of x equals to, this 3 comes in front, so it is 3 sine 6x by 2 by cos 3x, and I'll write this separately, 1 by cos 3x, this becomes 0, so we are left with cos 3x, and here it is 1 by cos 3x. So this is 3 ones are 3, 3, sorry, 2 ones are 2, 2 3 are 6, so it is 3 sine 3x by cos 3x into 1 by cos 3x. So 3 constant as it is, sine by cos is tan, so it is tan 3x into 1 by cos is secant, so it is secant 3x. So our next function is cos square x. Solution, f of x is equals to cos square x, f of x plus h is equals to cos square x plus h. So that is cos square, yeah, that's it. Now formula f dash of x is equals to limit h extends to 0 f of x plus h minus f of x by h. So this can be written as limit h extends to 0 cos square x plus h minus cos square x by h. So the given function is in the form of cos square b minus cos square a. The formula of cos square b minus cos square a is equals to sin a plus b into sin a minus b. So this can be written as f dash of x is equals to limit h extends to 0 sin a plus b is x plus h into sin x minus x plus h by h. Here this minus and plus gets cancelled, so it is f dash of x is equals to limit h extends to 0 sin 2x plus h into sin, here it is minus h, so the coefficient of h is 1, so it is minus 1 into h, okay, whole by h. Now writing the limits to both the terms, so it is f dash of x is equals to limit h extends to 0 sin 2x plus h into limit h extends to 0 sin minus 1 into h by h. So here substituting h value as 0, so it is f dash of x is equals to sin 2x plus 0 into, here the value will be minus 1, okay, that is equals to minus sin 2x, okay, minus 1 multiply with this, so it is minus sin 2x. So our next function is x sin x, okay. Solution f of x is equals to x sin x, f of x plus h is equals to, in the place of x substitute x plus h, so it is x plus h into sin x plus h. Writing the formula f dash of x is equals to limit h extends to 0 f of x plus h minus f of x by h. So this can be written as limit h extends to 0 x plus h into sin x plus h minus x sin x by h. So it is f dash of x is equals to limit h extends to 0. Here multiplying the x with the whole term and h also with the whole term. So it is x into sin x plus h plus h into sin x plus h minus x sin x whole by h. Now taking x common from these two terms, so it is f dash of x is equals to limit h extends to 0, taking x common, so here it will be sin x plus h minus, here we are left with sin x by h, plus for this term also it is h into sin x plus h by h. This h gets cancelled. Now applying the formula of sin c minus sin d. So the formula of sin c minus sin d is equals to 2 cos c plus d by 2 into sin c minus d by 2. So it is f dash of x is equals to limit h extends to 0 x into 2 cos c, this is c and this is d, so it is x plus h plus x by 2 into sin x plus h minus x by 2 by h, plus we'll write limit for this term, so it is limit h extends to 0 sin x plus h, okay. Now this plus x and minus x gets cancelled, adding the x terms here. So it is f dash of x is equals to limit h x tends to 0 x into 2 cos 2x plus h by 2 into sin h by 2 whole by h, plus now substituting the value of 0 in place of h, so it is sin x plus 0. Now writing the limits for both the terms, so it is f dash of x is equals to limit h x tends to 0 x into 2 cos 2x plus h by 2 into limit h extends to 0 sin h by 2 by h, plus here we are left with sin x. Now here this two gets cancelled, and no, don't cancel it now. Once we'll substitute the value of h, then we can cancel. So it is f dash of x is equals to x into 2 cos 2x plus 0 by 2 into, here it is a formula, sin a theta by theta is equals to a. So it is, here the coefficient of h above is 1, so here it is 1 by 2 plus sin x. Okay, now you can cancel this 2 and this 2, this 2 and this 2 also gets cancelled. So f dash of x is equals to x cos x plus sin x. So our next function is cotx. So given f of x is equals to cotx, f of x plus h is equals to cot x plus h. Okay, now writing the formula, f dash of x is equals to limit h x tends to 0 f of x plus h minus f of x by h. So this can be written as limit h x tends to 0 cot x plus h minus cot x by h. Now cot is cos by sine, so we'll write it as f dash of x is equals to limit h x tends to 0, write it as cos x plus h by sin x plus h minus cos x by sin x whole by h. Now taking the LCM, this term comes over here and this over here. So it is f dash of x is equals to limit h x tends to 0 cos x plus h into sin x minus sin x plus h into cos x by h into sin x plus h into sin x. Now here comes the formula, cos b sin a minus sin b cos a. So it is sin a minus b. So limit h extends to 0, sin a is x, a minus b is x plus h. Okay, cos b into sin a minus sin b into cos a is equals to sin a minus b by h into sin x plus h into sin x. Here minus and plus gets cancelled, it is inside minus h. Okay, so f dash of x is equals to limit h extends to 0 sin minus h factor is nothing but 1 coefficient, I mean, by h, this h. Okay, into 1 limit h extends to 0 1 by sin x plus h into sin x. Okay, so this formula is sin a theta by a, that is equal to minus 1. So it is minus 1 into 1 by, now substituting h value 0. So it is sin x plus 0 into sin x. So that can be written as minus 1 into 1 by sin x into sin x. So sin x into sin x is sin square x. And the value of sin square x is 1 by sin square x is cosecant square x. These are all important questions of first principle sums. Thank you.